Note taker and Jabberscribe. Let me say yes, you can do that. And we should be looking at your screen now.
Almost.
Almost.
It's dangerously
Yay!
close.
Excellent. I see it. I guess we're going to start off with the chair bit, which is actually, if you can go to the next slide. I guess is a. Do we have the agenda should be in here somewhere, right? Okay. Well, I can just sort of do this from. Let's go back. Let's start with the note well. Note well, very short. You will be recorded. Be nice. Be professional. This is an IETF meeting. The IPR guidelines apply. This is Friday. So you should have seen this note well at least once. There's a couple of links here you should have a look at. So the repo for all of this material is there on GitHub, loopswg IETF108. And notes we'll be taking in CodeMD, notes IETF108 loops, which is the link that you get to if you click on the Etherpad link from the data tracker. Could I bug people for note takers? Who would like to stand up and take notes?
Or perhaps saying it slightly different, who would serve the community by taking notes?
That's a much better way to put it.
Who would like to is asking a lot.
Yeah, who would like to? Who would like to serve the community? I'm going to start picking random names I recognize from the attendees list. Lee?
I can help with the note take.
Excellent. So go into CodeMD. So it's this link here from the.
Yeah.
Can we get somebody else to help Lee out?
And I put the agenda in there.
Yep. Perfect. There's a few people on the attendees list that I pick on quite often for this. Don't want to do that again. I'm looking at you, Tommy. Tommy has done.
I can do backup.
Backup. Perfect. Okay.
Perfect.
Thank you very much. Okay, we have note takers. Next slide. So the Karsten, can you hit the arrow? We've done the concise note well. This is the actual note well. Please have a look at this in the slides if you haven't seen it. Anything that you say in this meeting is a contribution to the IETF, and you should understand what that means. Next slide. So here's our agenda. We got 10 minutes for Spencer and I to sit up here in Babylon, which means we have 6 minutes left. I think we've got this tool fiddling, the scribe kidnapping. Jabberscribes. I can keep an eye on the chat room, but I'd like somebody else to be able to, I'm chairing this, so I won't be able to do that full.
Yeah, if anybody types in Mike : just let us know.
Yeah. Cool. And then we move on to agenda bashing. Would anyone like to bash this already well bashed into our time slot agenda? I love the 18 minutes at the end for calling the question. This is almost a Swiss railway timetable. Seeing no one in the queue and hearing no agenda bashes, we will start 5 minutes early and hand it over to Karsten. What is loops?
Okay, I switch on my camera so you see me once until my laptop has overheated. So this is the second BOF we are having on loops. We had one at IETF 105. So I'm going to run through this relatively quickly and focus on what has changed since 105. But of course, I need to do the whole thing so everybody knows what we are talking about. So basically, this is loops on one slide where we see that we might have an end-to-end path and between two hosts, and we might have a segment in the middle of that path that somehow is not so good. That's losing packets. And the idea is to apply some remedy in the network for this. So we have an ingress and an egress node, and these run something that looks a little bit like a transport protocol, but isn't one, for recovering those packets. So it can do reconstruction, it can do retransmission. Various ways of doing this are possible, but the point is the packet loss is recovered within this short segment, so this can be done faster than the hosts can do it among themselves in the end-to-end. And of course, the end-to-end principle applies. The host will continue to need to do this, and that also means that loops doesn't need to be perfect. So yeah, the first point is we want to recover packets locally. We want to reduce the end-to-end packet loss mostly for latency reasons, and use the lower latency we can get in the middle of the path. We want to do this in the network, so in particular we don't want to involve the hosts in that. The hosts might notice, but they don't need to know. And in particular, we are not peeking into the transport protocol. So I'm seeing some discussion on the Jabber that the slides aren't the right ones. Are we having a problem? Okay.
So I just uploaded new slides about an hour before the session. So that's what you're presenting, right, Karsten?
Yeah. Martin says it's broken. Brian says it seems to match.
Yeah. So the new ones are in the data tracker. So.
Yeah, but there hasn't changed much. So even if people are looking at the old slides, they should still see that. So Martin says meet echo is broken. Not sure I can do much about that.
Oh, okay.
Okay, so third item, don't look, don't touch. So this works with any kind of IP packets, in particular with encrypted ones. And we are not trying to help the end-to-end protocol, except by not losing their packets. So an end host sends some data, the loops segment transmits that. We need some form of X or other reverse information feedback, and maybe there will be a retransmission, maybe there will be forward error correction, and in the end, the data is reconstructed and sent on to the end host. So this is a pretty big area. We could do lots of things here. And in the initial meetings we had, we were going through these lots of things, and people were starting to get scared because it sounded like we wanted to reinvent the internet or something. That of course was not the point. This is a patch, a fix you apply to something that doesn't work right at the moment. So many things could be included in loops, and we are trying to follow a minimum viable protocol approach here, and make sure we have a protocol soon, that we have the energy to develop, that we have the agreement, that we want to that we are able to deploy this, and that provides enough benefit already. But it's not boiling the whole ocean, and we might build a few more dikes and add a little bit more of our ocean later. So recovering is done using retransmission, reconstruction. I probably don't have to say much about this. I left this slide in from 105 because we struck a few things from the list for the minimum viable protocol. So we're not talking about dynamic block sizes and rates of forward error correction or combined forward error correction and retransmission. We can add that later. And also we are keeping most of the setup out of the protocol. So this is a controller model. Something in the network sets up the loop segment, and then the loops protocol runs between the ingress and the egress node. We want to do this in a way that doesn't blow up the internet. We know that if we are concealing losses, we are removing an important congestion signal, and end hosts would ramp up indefinitely to higher rates and increase the congestion. So we discussed various forms of congestion feedback, and it's certainly possible to invent very elaborate ones, but these would need to be tested. So we came up with a very simple one, which is drop to mark. So any packet drop we see turns into a CE marked packet, and that's why we need ECN. I'll come to that in a minute. At the same time, we see that the host transfer protocols are getting better in certain ways, and we may want to design loops in such a way that it can take, that it actually works well with these improvements, but they are not a prerequisite for the protocol to work. Okay, so the three things are recovery, measurement, of course. We need to know the RTT. We may want to know the delay variation as well, so we can set the recovery parameters. And we are leaving out the ambitious goal of identifying non-congestion losses from the minimum viable protocol. So the congestion feedback is now entirely focused on ECN. We are not working with non-ECN traffic. So loops is, of course, interacting with the end-to-end protocol, transfer protocol, which is also trying to make sure that all packets make it. We are not meddling with that. We are also not assuming the end-to-end protocol knows that loops is in place. And in particular, the end-to-end protocol remains the one that controls the sending rate. So we have to make sure that the congestion control feedback the end-to-end protocol gets with loops looks very similar to the one that it would get without loops. On the other hand, loops is not a classical transport protocol, so some losses are okay, and also implementations might be able to interact much more tightly with the path segment being optimized. So if they know this is actually just a satellite segment, they might be able to do more than other loops implementations, but that's not part of the protocol. So the typical intuition for a transport protocol doesn't really work very well for loops. First of all, the environment is controlled. Somebody set up this loop segment, so they must have had a reason for that. These are not random end hosts that are interacting over random internet paths. We don't need full reliability. Since loops actually is aggregating, it's usually aggregating multiple end-to-end flows in a tunnel, it might have much more packets in flight than the typical transport protocol would over a segment that actually has losses. So there are a few drafts that have evolved over the last 2 years. We have been discussing this. The pointers are in the charter, so maybe the most important thing is to look at the chart. And we had a mailing list in case you haven't followed that. Okay, so that was a very quick run through loops. And now I want to focus on what happened from IETF 105 to IETF 108. So the 105 BOF was one that was labeled as non-working group forming, even though some questions asked at the end probably would have been better for working group forming BOF. Anyway, so there we kind of opened the design space and looked for feedback. And we got this feedback. Thank you very much. We got a lot of more feedback in the year since. So for 108, for this working group forming BOF, we made a few decisions. We briefly considered leaving out FEC, but we think we need to exercise the parts of the protocol that switch between FEC and retransmission. So we will include FEC, but it's a non-goal for this round to do a really great, state-of-the-art, super efficient FEC. As I said, we are not trying to detect non-congestion losses as such, and we are focusing on the drop-to-mark approach, which means we require end-to-end ECN and we CE mark the recovered packets. And finally, we decided to focus on one tunneling protocol, Genève, for now. So this is certainly a minimum choice. Well, not quite minimum. We could leave out FEC, but it's maybe not that much of an addition. Initially, we wanted to improve throughput and latency, and we saw that improving throughput actually is way more complicated. So we are focusing on latency now, on faster recovery. And that means the flows that we are interested in are really the ANDs, the short flows, and the transactional loads, where we have small bursts of traffic, schemers or something like that, and then go back to idle. And the reason why we want to do this is we don't want to have congestion control loops fighting against each other. So we just leave the congestion signals in place and let the end-to-end congestion control do its thing. Even though we might get better congestion control, but yeah, that maybe needs more work. Yeah, maybe the most important consideration here is tail loss, both for ANDs and for transactional loads. And of course, there are other people working on tail loss from the end-to-end side, and that's great. But we can attack the problem from both sides. So in a very short way, this is our problem statement. Packets get lost, and it can take a long time to recover them end-to-end. Now, this is a very broad problem statement, and quick and tail loss detection and so on will address this problem. So we are narrowing this a little bit to an opportunity, which in this case is we know how to improve this using local recovery, retransmission or reconstruction without host cooperation, independent of transfer protocols. And we are also narrowing the opportunity to ECN capable traffic. So we can do this very simple drop to mark, non-invasive congestion signaling. So that's why the problem statement for this would be very wide, and we really need an opportunity statement and not a problem statement. So the narrowing of the opportunity, of course, also means that the environments that benefit narrow. So we can only benefit applications that have ECN enabled at the end hosts, and that benefit from improved latency. And we looked at a number of applications. We will go to use cases shortly. And yeah, smartphones might already be ECN enabled. In the enterprise, we know that in many cases, ECN needs switching on, and the drop-to-mark approach actually is an incentive. So if you don't care about loops, but do care about ECN, maybe you should just keep in mind loops is intended also as an incentive to switch on ECN. And yeah, bleaching of ECN by networks is a problem, and we cannot do anything. There is a question in the Jabber, ECN is ECT0, since nothing else but ECT0 exists at the moment. Yes, but I think we will have good ways to interact with other forms of traffic later, but not in the minimum viable protocol. Okay, so back to the bleaching issue. We cannot, we cannot do anything about networks that bleach ECN. But what we actually can do is work around a network that is bleaching ECN by running a loops segment around it, converting the drops to marks, and run ECN in the in the adjacent parts of the network outside the loops segment. Yeah, the question that is often asked, a frequently asked question, is why don't you just simply fix your network? It turns out that the use cases that people have in mind for this involve heterogeneous or hybrid environments. So you have traffic that is crossing into operator boundaries, or traffic that is going through legacy areas in your network where you know the forklift upgrade will take another 3 years. So right now it's just not possible to do something. So think about the patch, not in the computer sense, but in the physical sense. You do this when you have some deficiencies in your network and work around that. And clearly, this is not for everyone. Google's internal network probably doesn't need loops. This is really more for people who work through very heterogeneous environments and find that they have to integrate networks that can use some help. Yeah, so more discussion in the Jabber about L4S. Definitely, this is something we have been following with great interest, and we also would follow SCE with great interest if that can ever happen. But right now we are focusing on things that actually are working. So I'll switch off my camera because some people are not getting my audio anymore. Sorry about that. Okay, so what are these heterogeneous scenarios? And we came up with 2 abstract scenarios that actually can be combined. One is the AA1B, AA2 scenario, which just means we have an operator A that provides a service, and it utilizes operator B for part of the network, where operator B might be a legacy component of its own network or actually a different operator. So A has little control about what happens in B and just wants to improve the situation between the hosts A1 and A2. And this is something where loops could be very useful. Another scenario is where an operator has end nodes and wants to provide a service together with another operator C, but they need operator B to get the packets flowing between lowercase a and lowercase c. Again, they can run loops between them, and this, of course, can be used to work against or around in unfavorable conditions provided by operator B. And these scenarios can then be combined into more complex ones. So the little squares here are not the end hosts, I should have said, but are routers that then branch out into the networks on which over which the end hosts then communicate. So why do we want to standardize this now? Actually, I have been wanting to standardize this approximately since 2008. So I'm happy that more people want to do this now. We actually think this is low-hanging fruit. And the interesting development that helps is that we now have overlay nodes we can get deployed all over the network, either in operator data centers or even in cloud provider data centers that can provide the compute and the space to make this happen. So I think that is one of the reasons why this hasn't been done earlier. It was harder to find these overlay nodes, but it's also just we just happen to have found applications in various parts of the world. Again, it's probably not so interesting in the middle of the US or in the core network in Germany or something like that. But there are applications where operators see use. And actually, there are lots of riverbeds and other other companies around that provide application controllers, or however they are called. And these often come from a background of intrusive PEPs, so they will have to change. But it's not like these solutions don't exist. We just don't see them in the standard internet protocol place, because these boxes are usually bought in pairs. And they are also often not done right. So my personal record for a round trip time was in a train in Belgium, where I measured a round trip time of 264 seconds through such a solution. I had to modify ping to even be able to measure that. Yeah, so not everything that's out there is great, and it would be good to have a standardized solution that points the way a little bit. So why standardize at all? The reason is that the ingress and the egress often are different. They might be run by different operators who want to make different choices in equipment, but they also might be in different ends of the network. So you might have an ARM-based CPE and operator data center at a virtual POP, and you might want to buy different solutions for these environments. So having a standard is actually useful. So with that, maybe we can have a quick peek at the use cases. So we have talked about use cases a lot in 105 and in various site meetings, and we're not trying to list all potential use cases here, but focus on some that actual operators have today. And again, it's not about changing the internet, it's about changing those parts of the internet that actually need this change or can benefit from this change. So, Iju, can you give the microphone to Iju? Thank you.
This is Yu. I'm going to talk about this use case called the overlay path via cloud. Actually, this was presented before during IETF 105, but here we're trying to refine it into the terminology used by the previous scenario, those square boxes here. So basically, this use case is a combination of the two scenarios covered by Carsten just now. If you look at the small blue squares, A1, A2, and A3, basically they are workloads created by us. They are located in different cloud, or possibly same cloud, but here for illustration purpose, we use different cloud. So the bigger blue square A actually is also our cloud. So the A2 is created from our own cloud. Then possibly there are other clouds which is green and red. We create workloads there. So if you look at the left-hand side, the small picture, we have the overlay nodes all around the world. There are more than 100. Some are from our own cloud, and some are created from other clouds. So with all these overlay nodes, we can possibly select a better path in terms of the lower latency. So for example, we find out the default path from Jakarta, Indonesia to Shenzhen, China, actually sometimes gives quite high RTT time, for example, like a few 100 milliseconds. So we try to use a two-segment based path instead of the default path that is from Jakarta to Hong Kong and Hong Kong to Shenzhen. And with this lower latency, 2-segment lower latency path, then we can achieve better latency, but we find out the loss is still there. From Shenzhen to Hong Kong, although the distance is pretty short, but because it's an international gateway there, it's across the region, so the loss is there from time to time. So we're trying to enable the loops over this particular segment to achieve the faster packet loss recovery. So I just want to point out, loops actually does not address any problem of the path selection or partition the path to segments. Here, loops only helps here to recover the packet over specific segments in a faster way. So that's what I'm trying to say. Thank you.
Thank you. So, Jianrong, can you say something about the China Telecom use case?
Hello.
We can hear you.
Hello.
Jianglong, can you try to reconnect? Here we go.
This is
Hello?
Jianlong.
Yep.
Hello.
I can hear you. Good.
Thank you. Okay, thank you. This is Jianlong from China Telecom. Many thanks for this opportunity to speak out our use case to you. And this use case is mainly focuses on the SD-WAN based branch office interconnect. As we all know, more and more enterprise customers choose to deploy SD-WAN services due to its flexibility and the lower cost. However, in most cases, SD-WAN is an overlay network service built upon the internet, which is best effort network. We found that the quality of SD-WAN overlay connection would be highly affected by the underlay network. So we have strong desire to enhance the network performance in such cases. Okay, as the picture shows, enterprise offices are always in different cities, such as Beijing and Nanjing in China. We had deployed at least one or two POP in each province for user with the nearest SD-WAN service access. So the branch office CPE connects to the selected POP in Beijing for service access, and then it will direct the traffic to another POP in Nanjing, which is close to the branch office site too. We can say that there would be 3 segments overlay paths in between of branch offices CPE. And there are CPE, CP1 to POP1, POP1 to POP2, and POP2 to CP2. And each segment should use network overlays by means of tunnels. Besides, from our current deployment status, CP to POP segment is based on the Internet access network, which is usually tens of kilometers, and POP to another POP can be hundreds of kilometers away through Internet backbone. So packet loss could happen on any of them generally. So we can enable loops on the CPE and the POPs. POP is used to deploy overlay nodes, and the loops function can be enabled on demand. Therefore, in this case, loops can be enabled over these 3 segments to recover losses and to achieve better data delivery in the best effort network. Finally, I want to say that as an operator, we can provide loops-based value-added services for SD-WAN users to ensure QoS guarantees. Apart from that, when we offer loops-enabled services for the enterprise customers. We will talk to the enterprise IT department that you should enable your clients to switch on the ECN in order that the TCP flows will client sending are ECT capable. That's all for this use case. Thank you. Thank you very much.
Thank you. Marcus, can you say something?
I'm seeing a little bit of discussion on this use case, some questions in Jabber. Do we want to bring those forward while Jianglong's still here, or do we want to go on to Marcus first?
I think that the questions are more of a general.
Okay. So we'll carry him to next. Good.
Yeah.
Marcus, you're up.
Yeah, Marcus speaking. So we from Deutsche Telekom see loops potentially to improve multipass. So in the context of the minimum viable protocol Carsten already mentioned, that does not mean that we extend loops with multipath capabilities. It just means that an existing multipath environment, an existing multipath protocol can leverage loops. So no integration here, at least not in the beginning. Maybe later on if the charter becomes extended by multipath. So let's see. So I've sketched here two use cases. On the top, I see that loops can be used on individual paths between a multipath communication. So you see on the left side a multipath scheduler, on the right side a multipath aggregation. So probably there is some kind of multipath protocol between scheduler and aggregation applied. And then individual paths are using underlying loops. So the path becomes a tunnel through loops, which can help to improve the path robustness, probably to overcome packet loss, which would affect then the overall multipath connection in a bad way. The other scenario is below, is on the bottom of the page. So here we apply a loops connection through a multi-path protocol. That means we apply loops end-to-end, multi-path overarching or overlaying, and with that we hope that we can cope with, or that we can compensate multipath caused imperfections. So if we have scheduling mismatch or aggregation mismatch, then loops might recover packet losses caused by such a mismatch. So that is the idea here. Mainly we see loops to improve multipath protocols which transmit data non-reliable. So we don't see it, for example, for multipath TCP. But exemplary here I mentioned in the slide for multipath DCCP, or even in future for multipath QUIC if it makes use of the datagram extension. So thank you.
Okay, thank you, Marcus. I think that we're having some interesting discussion in the Jabber. All these use cases, of course, involve more than two network components. And these other network components obviously do something useful as well. It's pretty hard to construct a use case where you only see the loop segment, because then it's kind of trivial. So the use cases we have seen actually show complicated scenarios, but that doesn't mean that loops needs to handle all aspects of that scenario. Loops only handles the packet recovery part. So things like path selection, routing, and so on help with achieving the overall goal of each of the use cases. but there is no direct interaction with loops except maybe from measurements that loops is making and making available to those other functions.
Karsten, this is Spence. Do you want to advance to the next slide?
It's kind of leading over to the next slide.
Yeah, thank you.
So that's a chair slide. I'm not going to say anything about that.
So we put this here to like basically whether we, whether this is a like in a 5434 situation, this would be a hum. I think that there's probably enough traffic in the back channel on Jabber to show that we don't yet have like the answer to, does everyone understand the problem that has been presented, is in detail not yet. So let's actually let's take some of the discussion in Jabber and bring it out into the room. If you have questions here, please go ahead and get in queue. And first we have Gory.
Hi, does this work?
It does.
Excellent. So we talk about using ECN end-to-end. What's Loop's position on using paths that have ECN in the underlay? Does it allow ECN on the underlay, or is this only for networks that don't support ECN in the underlay?
I think that ECN in the underlay is orthogonal. I'm getting a lot of echo here. So for a while, we might further simplify the scenarios by requiring ECN in the underlay, but we found that we actually don't need that, because we can convert the drops that are happening there into marks at the egress. Indeed, one of the applications of Loop is to mask a non-ECN capable segment from the rest of the path by converting drops into marks.
So, Carsten, if you had ECN in the underlay, then you would want to react differently to drops than marks, because queues that are dropping when they're using AQM might be dropping because they're trying to shed load. And yet it seems that Loops translates these intentionally introduced drops into marks, and therefore doesn't cause them to be seen at the endpoints.
Yeah, but you always have the situation that in a path you don't know which of the routers there do ECN marking and which still drop. The majority of the drops will be from routers that actually haven't implemented ECN yet, or haven't implemented ECN right yet. So I think converting these drops to marks is innocuous. And if there's actually something bad going on in the loop segment, and I probably should have had that on one side, you would use a circuit breaker to make sure that you are not completely swamping that segment. So that's actually an important part of the overall picture, and I don't know why this is not on the slides. I'm sorry about that.
Okay, I think exploring that circuit breaker might be something that is interesting, but I'll finish my question there.
Okay, thank you. Next we have Colin.
Hi, can you hear me?
Yes.
We can.
Yes, good. So I just wanted to clarify my understanding of the scope and see if it matches that of the people proposing the work. So what I thought was happening with loops was that it was essentially a fancy tunnel. It was a tunneling protocol that could recover packet losses and turn them into ECN marks. The use cases seemed to be a lot more general, and they were talking about routing in different directions and multipath and so on. Am I right that loops is just focused on the tunneling part, and the rest are other things which use loops and are out of scope? Or is the scope of loops big enough to cover the rest of it?
No, the scope is limited to the recovery part. And as I said, the other parts are in the use cases, because the use cases are hard to understand if you don't know what else is going on in them.
Okay, next up we have Martin.
That is amazing. Okay, so I was a little confused by some of the presentations here. I think if you've answered Colin correctly, when you have, if I understood the answer, sorry, fancy tunnel, if your route selection causes you to go down that tunnel and that tunnel has loops, then you get all of the purported benefits / drawbacks of what's going on. Is that right?
Yes.
Excellent. That's a whole lot clearer. Now I can move on to the next question.
Can I quickly qualify that? Loops needs to work in cases that packet assignment malfunctions. So the ingress will actually have to look at the ECT bits to find out whether it actually can do repair or not. So there is a little bit of traffic sorting going on in the ingress, because we don't know how to signal congestion to non-ECT traffic yet.
Okay, so that's just a choice of how you manage the signaling, and so you basically opt out of doing anything for those people who don't do ECT.
Right.
Okay, fine. Doesn't this add a massive amount of reordering?
Yes.
Okay.
So that's maybe one of the differences between DetNet and loops. DetNet was brought up in the Jabber. DetNet has to make sure the whole thing looks like an Ethernet after it has done its work. And well, that's a very, very brief way of saying it. So it has to actually handle the reordering that it introduces. And DetNet therefore also has a resequencing function. I forget how that is called at the moment, the O in the pre-auth name. So all the packets are delivered to the application in the same order. A loops implementation has everything to do that if it wants. So if a loops implementation wants to present a perfectly ordered packet sequence to the application, then it can do that. But that's not part of loops. The loops protocol is not designed to help or hinder that. That's an implementation choice.
So I guess the question then becomes, if the application in question is not tolerant of that degree of reordering, and for instance, if you decided to retransmit a packet that is a little too late, how much, and that displaces other packets causing latency. Certainly repair would cause latency, but if it displaces packets causing latency, how is this necessarily a good thing in all cases?
Well, first of all, you would not run loops in such a way that the displacement effect becomes serious, because we are talking about small two-digit percentages here. We are not talking about creating 3 times the traffic or something like that. And the second observation is yes. So anything you can do to packets has a few people who heavily benefit from that, and others who might see a slight impairment of their traffic. There is no way to ever touch a packet without having the possibility of some impairment.
Okay, thanks. Next, and I'll go ahead and close the queue after this, Jana.
Can you hear me? I think
Yep.
you can. Okay, Jana Iyengar. So I want to follow on to what Martin just asked and broaden the question a bit, because that's what I got in the queue to ask. how do you? So there's no application classification going on here, or if there is, it's not in scope for loops, right?
Can you say it again?
There is no application or traffic classification that is in scope for loops. Is that correct?
No, that would happen outside the SDN, SD-WAN, whatever application would figure out which traffic should be sent to loops and which shouldn't. But of course, we need to design loops in such a way that it's not massively detrimental when misassignments occur.
So I think this is where I'm getting stuck. I'm trying to understand the context in which loops gets deployed, and it's failing me. So this to me sounds very much like what already happens around problematic links. Wi-Fi is a good example of that, where we do local retransmits at the link level. And satellite networks, again, you might want to do that, but that's sort of around one IP hop typically. That's how we think about that. And the reason it works in those situations is because you know that the path has particularly poor loss characteristics, and doing some sort of local recovery around that particular link is helpful. But turning it to the IP level means that I can do it across the internet. I can do it from my house to the Google data center or to wherever I want to do it. And that's where it starts to become much more problematic for me, because it starts to work on aggregates of traffic without, and at that point I'm trying to figure out how does loops selectively apply this only to the traffic that cares about having that sort of retransmission. I mean, in the extreme case, I can imagine a loops endpoint at my computer here and at the other end as well, and there being basically a reliable tunnel between the two endpoints. Again, without the context, it's not clear to me exactly where and how the loops gets used. Now, I saw the use cases, but again, the use cases didn't help me understand the context, meaning what is the technology around loops that is helping loops do its work effectively.
So you made the observation that we're doing this in link layer adaptation protocols all the time. So Wi-Fi uses retransmission and also resequencing, one might say. The question really that comes up very quickly is, if that makes sense for one hop, why doesn't it make sense for two hops? And so loops is kind of the generalization to the answer to this question. Of course, it makes sense in certain situations, in certain cases. So you can do a lot of things to actually make the loops mechanism be really optimal and selecting the right application traffic and so on. But simply switching on loops for a particular segment on which traffic is flowing should have some positive latency effect for that traffic. So that's really the goal here. So it works without all the other things, but all the other things help.
So I don't want to rat hole here, but what you just said is actually completely contrary to my intuition. What you just said is, if it works for individual links, why not generalize it? My question is I'm asking the question, it makes sense that you want to deploy it for individual problematic links. And my question is, why generalize it? When you don't know about the links that are in place, you don't know the latencies of the links that are in place. And if you want to generalize it, I'd like to understand how one is supposed to understand the extent to which this property is generalizable.
So the loops, of course, has to make some measurements about the segment, so we know something about it. But indeed, we may not actually know the reason why packets are lost. And if you talk to operators, you will be surprised. They also sometimes don't know the reasons why packets are lost. I think you are overestimating the amount of intelligence that actually is in link layer protocols about retransmissions these times. So this is to a certain extent still pretty basic, and I think we can even do better in loops than for some of the legacy protocols that are out there in use today.
I would disagree with the characterization that I'm overestimating the intelligence in link layer protocols. I'm simply saying that link layer protocols occur at a link, not across IP hops. And that's
Yes.
a pretty fundamental and important characteristic.
Yes.
When you're going across IP hops, you have significantly congestion as a big signal, as a big reason for loss that can happen across IP hops. And if you try to put loops because you start to see congestion, I'm not quite sure what happens. And this is again why, I mean, link level retransmission is a property of the link. It is exposed up to IP. IP doesn't see those losses at all. It might see some reordering, but typically link level protocols have buffers to manage the reordering. Are we talking about doing buffering here to manage the reordering? No, we are not. We're talking about simply retransmitting, which again may not actually help you at all, but it's not clear to me. It's not clear to me. It depends on the scenario in which you deploy it. It depends on the latency of the loops segment as a ratio of the end-to-end latency. So the only thing I'll leave with is that it is important, very important to consider that any recovery that loops does has to be seen in the context of end-to-end recovery that is happening at the sender. So if the sender is doing FEC, the sender is doing loss recovery, will loops know that? Does loops interfere with that? Does loops help that? Under what conditions does it help? Under what conditions does it hurt? Those are questions that are still open in my mind.
Yeah, so the answer to the question, will it know that? No, it won't know, because loops does not look into the transport protocol. Will it improve that? Well, if there are losses and there is still a budget to fix them by repair, yes, it will repair them, and it will happen within the segment, so it will be faster if it's retransmission than it would be end-to-end. And I forgot the third question.
Well, what conditions does loops hurt under? But
I'll take
Brian, you can take
that
this
as a
offline.
question.
And
Yeah, I'll take that as a question as input to the chartering, because we are currently about 6 minutes over on this part. Ichao, did you have a point on this discussion? Or did you have an additional question? Because we closed after Jana.
I try to be quick. So I want to add something to Carsten's comments as well to answer why this loops. I mean, under what circumstances loops would be required. For example, the underlay, the infrastructure operator actually is a different one from the overlay network operator. So in that case, the overlay operator doesn't really know what happens on the lay. There is another case that even for the infrastructure and the overlay network, they are owned by the same operator, same company, but it could be run by two different departments, because normally the overlay network can be provisioned much more quickly than to change it underlay. So there are some of the operators actually have the choices to use the overlay network for their quick provisioning on certain services. In that case, they try to use the overlay. In that case, the overlay department who is running this overlay network actually has no way to understand what's happening under for the underlay network. So that's why loops could be used there. But trying to point out, loops actually itself doesn't solve this all kinds of problems. Loops just try to provide the packet recovery. Yeah.
So if I can interject here and to try and wrap this up, it seems like there are three sort of actors that we need to consider. There's the in this overlay underlay case, there's the overlay operator, the underlay operator, and then there's sort of like, whatever happens at the endpoint for recovery. From the overlay operator's standpoint, if I can try and restate what you said to make sure that I understand it, the overlay operator is essentially using loops in order to emulate a certain set of network characteristics on top of an underlay operator that does not provide those characteristics that with respect to loss. That's correct? So you're basically trading off jitter for loss on a lossy link that you get from the underlay.
Yeah.
Okay. So I think that, so Jana's question was in terms of sort of the sender and the network, and your clarification is in terms of like the two different networks. And I think we actually need to consider sort of like the context of all three here as we go forward. Is that a fair characterization?
Yeah. 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 The second case is for the underlay and overlay. Actually, they are belonging to the same operator, but they tentatively to use it in that way. So that's also the case. I just want to add this. Yeah.
Okay.
So if Brian, if it's okay, I can make a small quick comment.
Please do.
There's a fundamental assumption in all of this, which at least I'm hearing, and if I'm wrong, please correct me. And I'm hearing that loss is fundamentally a latency-inducing thing that is bad. That is a strong assumption of what the endpoints are capable of doing, or what the traffic needs from the network. Typically, when we build endpoint protocols, we assume that losses will happen in the network, and we build around it. Losses are an indication of a variety of things, and they do not always introduce latency. And importantly, I'll say that hiding losses can actually be problematic in cases of congestion, and a high loss rate is not necessarily a bad thing. I'll give one example, which is the BBR congestion controller actually reduces latency while increasing retransmission rates. That's always confused people, but that does happen. Yeah, and I'm happy to take more questions later to the end, but I'm definitely listening curiously.
Thank you. So I think this is actually the, stepping back with the chair hat on, I think this is actually one of the conversations I really wanted to make sure happened at this BOF, was because sort of like loops is proposed very much with sort of like this network and operations viewpoint, and just sort of like making sure that the impedance is matched between that and transport protocol design. But with that, I think, are there other questions that people have that they're really having trouble understanding what's going on here before we move on to the charter? I think we have definitely points that have been raised for the design that should be considered, but are there sort of like, I don't know what's going on here questions still? Seeing none, I'll hand this back over to Karsten to start looking at the charter. Oh, wait, Emil, did you want to ask? You also have to put yourself into, You also have to put yourself in the audio queue, otherwise we won't be able to hear you.
Yeah, Stefan is trying to share a screen, which is maybe not what he wants.
I am having trouble getting Emil in. Emil, can you put that into the chat? Hold on, okay. I am not able to add Emil.
No, he has to press the microphone.
No, he did press the microphone. I try to add him. I try to press the microphone to add him, and I get MP not found.
Oh, okay. So his browser doesn't have microphone permission.
Okay. Yeah, can you add that to the? Can you have that in the Jabber, and we'll try to pick it up later. Karsten, can you move on to the charter stuff?
Yes.
Looking at the clock.
Okay, so I just pasted the charter text on a slide, which is unfortunately the best way I know how to handle this. The charter proposal starts with some background, and I think most people will be able to agree with the first slide here. So I'll go on to the part that is not background. So loops is there for enabling optimizations within some segments of an end-to-end path. And then the charter points out this is best done by tunnels, or in loops, this is done by tunnels. And these tunnels are for aggregates, so many end-to-end flows can go into one such tunnel. And the focus is on path segments that do not include the end hosts. Of course, there is no technical difference between including an end host and not including the end host, but that influences the choices that will be made, in particular on the setup side. So the assumption is that the ingress and egress nodes are actually under control of some network operator, and multipath is left for future consideration. Again, the selection of the segments to be optimized is out of scope, and I think we just discussed this sufficiently. So there is some network configuration going on, and I apologize to the people who are kind of scared by network configuration. Network configuration is scary. And on the other hand, this means the network configuration can supply parameters to the loop's operation. So we don't have to have a protocol that is entirely self-controlling, but of course it's better if it is, because these parameters could be configured wrong. So we are assuming there is a key value configuration data set that is used to do the setup. Yeah, so this just repeats, we do recovery, we do measurement, and we interact with end-to-end congestion control. So the recovery can be FEC or non-persistent retransmission. And I think this is very important, so that there needs to be a time limit. You may not have to specify this very precisely, but the assumption is that retransmission is time-bounded, and there will be at least one FCC scheme in there, and more advanced ones can come in later. We need to do some measurement, and these may actually be interesting for the network management again. And finally, we have an interaction with the end-to-end congestion control, and we do this by relaying the loss events that happen on the segment as loss events to the end-to-end congestion control. And since relaying would mean dropping for a non-ECN flow, that's not very great for someone who wants to recover packets. So we focus on ECN-enabled end-to-end flows. And very important, we will use circuit breakers to make sure loops doesn't aid and abet bad behavior by end nodes. So we also need a tunneling protocol. Loops itself is somewhat agnostic, but we will focus on Genève for now, but we also will keep in mind that we will add some tunneling protocols later. There are two IETF research groups that we will need to actively work with. ICCRG, of course, for any second-order effects that this might have on congestion control, and the network coding research group, because that's where FEC work happens. So if we do something stupid in the way we accommodate FEC schemes, we want to know that. Yeah, there are a few other IETF working groups, but these are weak relationships. Of course, Transport Area is doing some FEC-related work, transport area and TCP/M are interesting, and NVO3 is interesting as the home of the Geneva Tunneling Protocol. Thank you, David, for this correction. So maybe FEC is not going to be the focus of the monitoring we do in the transport area. Oh, that was all. Yes. So, discuss.
Karsten, you may want to go to the next couple of slides that talk about the questions on this. And I'm thinking, like, start with the second one down. Is the draft charter here as presented here ready for the ADs to take forward? And if not, is it close enough to polish on the Loops mailing list and during a chartering review process? Thank you.
Yeah, these are going to be the ones that we ask at the end of this discussion. And as you are, if you're making a specific point on the charter, try to like preface it with where in the charter you'd like to discuss. If it's a more general scoping question, because those are also sort of like we're past clarifying, we should be talking about scope and things like that now. If you have a more general scoping question, you don't need to point to the charter, but please do refer to that. And Carson, if you could go to the appropriate slide when we're talking about that, that'd be great. So with that, Colin.
Hey, so a couple of things on the charter and so on. I think someone mentioned in the chat already, the network coding group is planning to wind down over the next year or so. So, I mean, while it makes sense to talk to those people and talk to the people with the FEC and network coding expertise in general, do bear in mind that that group is not likely to be massively long-lived. As a general point, I don't see any list of deliverables or documents on these slides. But I think the discussion earlier would seem to indicate that some sort of a applicability statement or guidelines for operators on what environments it would make sense to enable loops in would be a useful thing for this group to produce. You know, the sort of thing that says, you know, if you have paths with your round trip times more than X milliseconds, you probably don't want to be enabling loops because the added delay and reordering will cause problems. Type of document. And in terms of the overall approach, this seems like a reasonable engineering problem. I think people are going to be building this type of product anyway, whether or not we standardize it. So I think the IETF should standardize it, and I think understanding the applicability is probably as important as the specific engineering choices of how it fits in with Geneva and so on.
Well, thank you. Gory? Gory, go ahead. We have been able to hear you in the past, but I cannot hear you now. Maybe you should click the little round thing in the lower right corner.
After clicking the little round thing in the lower right corner, does it now work?
Oh yeah, well, cool. 2 for 2. Go ahead, Gory.
Okay, so on bullet 1, it mentions 3135, the PEP RFC. And one of the things that RFC was very clear about was that PEPs had to be known by the endpoints that were using the service. That you shouldn't just trade loss for recovery or make trade-offs in the network. You should have this somehow configurable. So I'm wondering really whether that should be brought out a bit more. I'm worried about operators who have traffic engineering teams who try and engineer around loss and other mechanisms that this is trying to also engineer around, doing it at the same time, and how these work together. Have people thought about that as a possible thing to include in the charter?
Hello, thank you, Spencer. I pointedly got out of the. You can't really change your hats here, but I for people who are actually watching the queue, I went into the queue and got pulled out of the queue by Spencer because I am speaking as an individual, not as the BOF chair here. I'm actually looking at this charter again in the context of some of the discussion here, in the context specifically of Gory's question. The question that you asked, Karsten, is this a minimum viable protocol? And what is, I think I want to reiterate that one of the things that's actually missing is some sort of way for there to be signaling beyond ECN as to whether or not an endpoint wants to participate or wants to opt in or opt out for certain traffic, right? Like, so this is basically seen as a way to sort of bulk emulate one loss profile on top of another loss profile by a network operator. The point that Jana was making earlier, it sounded to me like boiled down to you might not know what's happening on that underlay network, but you also don't know what's happening on the endpoint, and what's happening on the endpoint might like change the network, change the properties of the network response such that you're actually dealing with an entirely different environment in both the overlay and the underlay. So I'm wondering if there's not some sort of interaction with a signaling layer missing here that should be added to the charter. Like there should be some way for end-to-end traffic to say yes, please, or no, thank you. Would be my feedback on the charter. Otherwise, I think, as Colin said, a lot of this is happening right now anyway. A lot of it is happening with performance-enhancing proxies that, contrary to what the RFC says in the shoulds and musts, are working already without endpoint cooperation. There should be a place that we can at least talk about experiments in this space in the IETF. It does seem like engineering work. So I do, as an individual, think the draft charter is probably not quite there yet. I mean, look at my comments, but I think that it can be polished into something that would be.
Yeah, thank you, Brian. About 25 years ago, I was part of something that became the ISSLL, Integrated Services over Specific Link Layers. And about since that time, I have been telling people parts of the network need to know what the intentions of the application are. So I called this intention signaling. I've never been able to actually get any of this into any of the protocols. Yeah, I completely agree that intention signaling is a useful thing, which is very, very different from the end host trying to command the network to do something, which hasn't worked out very well. But the network can benefit in many places from knowing more about the intentions. And of course, there are privacy considerations there and so on. And yeah, I mean, you are running PNRG, so I don't have to say all this. In this working group proposal, we try to steer clear of this, but I completely agree that some form of intention signaling would be extremely useful. But I wouldn't want to do this in this working group because it's a much larger problem than the loops problem itself. But I would like to pick up the results anytime.
Martin, go ahead. Martin
Hi,
Duke.
Martin Duke. Yeah, I mean, certainly this presentation has started with a proposition that should be completely transparent to the endpoints, and I think we're hearing some feedback from the community that maybe there should be some explicit coordination with the endpoints. I don't know if people want to stand up and say that's a bad idea. Could this be, maybe this is a dumb or naive question, but could this be as simple as a DSCP?
If DSCP were deployable in any way, so end hosts can use it, that would be exactly the right way to do some intention signaling. But I mean,
well, for an experiment, is that like okay?
Martin
Yeah,
Thompson.
stick it in the plus header. Brian had the right answer. Stick it in the plus header.
Yeah, I just won the jackpot. I think there's a fundamental problem here in that these enhancements are going to be applied over a fairly long span of the network, which means that there's going to be additional latencies for any repairs, or there's going to be FEC. And these things aren't free, and they may actually interfere with what the endpoints have to do and want to do. And as this is explicitly something that's not dealing with getting signals from endpoints, and I think that's on the basis of the description of what I've seen here, a reasonable conclusion to make. But I don't think that's particularly good. But I think Colin did convince me that with an applicability statement, this is at least not doing harm. I think without an applicability statement, it would be actually quite harmful for end users, because without knowing what's going on, you're potentially wasting effort or, in fact, interfering with what's going on end to end. And I don't want to tell you what's going on end to end, because I think that's a bad way to go.
Brian, this is Spence. Did you take me out of? Did you take me out of the queue?
Were you in the queue?
Yeah.
Oh. Okay. Do you want to be an individual, and then we'll take Jonna, and then I'm going to go ahead and close the queue because we would like to wrap up. Go ahead, Spencer.
Yeah. So the thing about the thing that we were talking about, the endpoint signaling, is 3135 was a beautiful thing. I was co-chair of the working group that produced it, but the PAN-RG draft on what not to do talks about endpoints not trusting the network and the network not trusting endpoints enough to where I think I'm more comfortable now with the network elements making side deals between themselves than I would have been in 2002 when we published 3135. Over to you.
So, Jonna, with closing remarks, please make them brief. We're 2 minutes over.
Leave closing remarks to the chairs. I just have my comment to make.
Closing question.
It's a comment.
Okay.
That at a high level, there's a big difference which I'd like to see pointed out between this and, as I was pointing out earlier, link level retransmissions. That link level retransmissions operate under IP, and this is happening across multiple IP hops and above. It's happening in the overlay. We use multiple languages here, such as overlay, underlay, and various other things. The nice thing about doing it at the link level is that that link level technologies that use it know that the RTT, for example, is a small fraction of the end-to-end path. I can buy that, having an applicability statement can narrow down the scope of where loops gets used to only places where it makes sense. Unfortunately, it's still not clear to me that we understand where it does. Now, just because an operator deploys it, and operators deploy snake oil devices all the time, that doesn't mean we should go standardizing them. I'm also not hearing that there are operators screaming for a standard in the space. So while operators might be doing it and they might be deploying it here and there, it is not fully clear to me what circumstances they do it under. And it's not clear to me that they need a standard here. My fear in having a standard here is that it becomes something that is easily deployable willy-nilly in arbitrary places. And I fear that an applicability statement may not be enough to prevent that from happening.
Spencer, are you coming from the floor on this?
I think so. So the speaking as a former area director a long time ago about this, one of the buffs that Martin and I did not end up chartering was tunneling, compression, and multiplexing traffic flows BOF that was like IETF 8889, something like that. And, we had the concern then that, is anybody going to need this badly enough to do it? And it turned out that after we didn't charter it, we found out that most of the people who needed it were in Africa and were not at IETF 8889. So I'm not saying anything about whether that's the same case here or not, but I did have that memory that I wanted to share with the group. I'd shared it in private email, but it seemed worth saying.
So, thank you, Spencer. So we got 13 minutes of an 18-minute thing to call the question. Let me see if I can summarize what I've heard in this discussion and summarize what I've seen in the Jabber chat as input to sort of a way to move forward. I think there's a definite. I actually, you know what? Let's actually. I want to use the hum tool because I've never done this in Meet Echo. I actually do want to take a hum on the first question first. So let's actually get a sense of the room of the 93 people here. We think we kind of understand the problem in the solution space. Let's actually take a hum on, is this a problem that should be solved in the IETF? So if you believe this loops is describing a problem, so this definition of multi-hop transport recovery, the fancy tunnel solution. If you believe this is something that the IETF should address, please hum now. Using the hum tab, which is the thing that looks like a graph next to the thing that looks like next to the chat tab it's the third tab in the left pane of the window.
Are people humming successfully?
Yeah, so enough people hummed successfully that was a forte. So that was a pretty strong hum. Let's take a hum on the other side. If you think that the problem that Loops is trying to solve here should not be solved in the IETF, please hum now. So when you're trying to find the hum button, 35 seconds feels really short, but when you're waiting for the hum to come in, 35 seconds feels really long.
We'll be smarter at IETF 109.
Okay. We have forte for yes, forte for no. That's
so if I could make a friendly amendment,
yeah,
could we do this for is doing an applicability statement a thing that we should do, yes or no?
Yeah. Okay. So, do you want to? Do you want to phrase that a bit more formally, Spencer? And I'll click the hum button.
Is this a problem that we should do an applicability statement for? Yes or no?
Okay. So the first hum is for yes. another Forte. If we get a fourth Forte hum here, I'm going to wonder if the tool's working. So the second hum will be if you think it is not useful to have an applicability statement on sort of the space in which something like loops could be deployed, please hum now. This is for no. I think I'm going to put in a feature request to Meet Echo to actually add synthesized audio hums while the hum tool is working. Because I'm not used to calling a hum for everything and it's complete silence. It's just a little weird. Pianissimo. Okay. Jana, you'd like to comment on this?
Clarify.
Yes.
Clarification question. It's not at all clear. I think there's on Jabber you can see there's confusion around exactly how the second question applies to the first one. Meaning, what does that have to do with
so the second question, as I understand it, and correct me if I understood this incorrectly before calling the question, Spencer, I understood basically the question was, is it useful for us to look into the applicability of technologies like this? And that was actually pretty clear. So that was, I mean, unless a bunch of people didn't hum no because they didn't know what was being hummed.
Yeah, I didn't say anything I didn't try to explain that during the middle of the hum because that seemed like a hostile act. Maybe that would have been better, but thank you for translating.
Is that independent of working group or not?
So I did not think it would be, I would not think it would be independent of working group, but like actually we could discuss that a little bit, right? Like, so the question is, does it's entirely possible that it doesn't make sense for us to charter a working group to standardize this, but it does make sense for us as a body to experiment with this. Would that be
maybe I can ask my question more precisely.
Okay.
Just asking if, when we're talking about the applicability statement, are we talking about the applicability statement independent of anything else? Like, I think there's a fair amount of interest in actually thinking about an applicability statement.
Yeah.
But if the question is preconditioned on, well, if the working group is formed, then should we work on an applicability statement, is a very different question than blanket, should we just work on this applicability statement?
So so we have plenty of
which one are we asking?
We have plenty of area directors on the call to answer the question, but one answer that they might choose from would be that's the kind of thing that you charter the working group to deliver the applicability statement and then recharter.
That would be one way to do it. I'm going to take actually Gory and then Lars each for 30 seconds because I'd like to give Martin 5 minutes as AD. Gory, go ahead.
Okay, I was only speaking as TSVWG chair, saying that this is a transport network, perhaps operator interaction thing, so it's well within what we normally do in TSVWG to think about this.
So you'd say that TSVWG could take on as a deliverable, a loops-like applicability statement that could then be input to sort of a future chartering of this group.
Yeah, or just discuss that topic.
Yes. Okay. Cool. Thank you. Lars, go ahead.
Hey, so I don't quite understand why an applicability statement needs to be done in a working group at all, right? This should be the proponents of this work. If the ask here is that the applicability statement should be done, it's up to the proponents of this work to do this, in my opinion, before we have anything chartered in the IETF, because at the moment we don't quite understand what this is, right? And given that we had a pretty split hum just earlier, whether the IETF should do anything, I'm feeling pretty negative about this attempt to sort of put a positive spin on this and come to something where we can say the IETF will do something in this space now. In my book, this is pretty clear, and more work is needed before we can have a discussion whether we should do something here.
So go do the applicability statement and come back if that's a rephrasing of what you said.
Yeah, I want to read that first before I decide whether or not it should be something that TSV will publish, right?
Right. Okay. I don't know, we got 4 minutes left, Spencer. So I think it's pretty clear from the discussion that we've had that the draft charter as presented here is not ready for the ADs to take forward. I think one of the things that I've heard as a possible way forward is write this applicability statement, work on it with transport input, possibly in TSVWG, and then take that as an input to a second working group forming BOF. I think that's what I've heard as outcome. But Martin, as AD, could you come and give us some closing thoughts on this?
Yes, thank you, Brian. I would agree with your assessment of the sense of the room. That I don't think people are ready to set this up as a working group. I think having an applicability statement in TSVWG is a fine idea, and hopefully that wouldn't push the can down the road too far. I would also encourage proponents to, I mean, there are certainly a lot of open research questions here, and I would encourage proponents to maybe do some of the research rather than just kind of wait around for this to happen. There's certainly a lot we can learn out there to make a lot of the unknowns clear before we try to charter next time. And I don't know if Colin wants to point them to a particular research group or not to house that work, but I think that would be a wise thing to do.
I mean, Jonah is on the call and may push back violently against this, but I might suggest that the congestion control research group wouldn't be a bad place to have some of these initial discussions.
I was actually going to call Jonna out if you didn't. So, Jonna.
So now the real BOF starts.
But in the 2 minutes left, or whatever time you have, I'm not convinced that this is limited to congestion control. I think this is a broader transport level problem. Not that I want to punt this. I think this can be a very interesting discussion, and the document can actually be useful. As people have been pointing out, these devices exist. And if we can give guidance as to how these devices ought to be deployed, where they are deployed, I think that could be actually quite useful. But yeah, I mean, I think it's not unreasonable to put it in ICCRG, but I think this is it's a broader transport problem.
Yeah, I think I'd agree with that. If people are going to write a document, it should probably be discussed in ICCRG. It should probably also be discussed in TSVWG, TSV area, and the like.
Yeah,
I don't think we're setting up a long-term work item of any of those groups. We're doing a relatively short-term bit of work that gets discussed in a bunch of places to see if there is then if it then makes sense to do the longer-term bit of work.
Karsten, would you be available and willing to drive this forward sort of in the, I'm used to saying Bangkok timeframe, but I don't actually believe we'll be in Bangkok. So the 109 timeframe?
So when you say this is getting started in transport area or getting something that we can discuss on a second BOF?
Getting something that we can discuss in the transport working. I think we need a little bit more sort of like exposure to wider parts of the transport area here. So something that we can discuss in ICCRG, in TSVWG, and that would be, so the outcome of those discussions goes into that document, and that's an input to and a deliverable before the second BOF. Does that seem reasonable to you?
We should probably talk about the venue.
I'm sorry, go ahead.
I was just going to say we could talk about the venue offline and figure that out.
Yeah.
But somewhere.
Okay, so take all of my venue information and say, for example, then.
Yeah.
In my question to Karsten.
Sure.
Okay.
So I was going to say we were forte on, is this a problem that should be solved in the IETF?
We're also forte on not.
But my point, but the point I was making was that saying, we're going to go from forte to dump this on Karsten and the other proponents seems like a real shrinkage on the amount of resources. So I hope that people who were humming forte pile in on this. So one of the things that we need to do is make sure that the people who piled in Forte know where the venue is for them to contribute.
Yeah. So I think that the discussion on this, like on looping this, or looping this up, spinning this up, should be on the loops mailing list. I would second. Yeah. So Lars is saying in the chat, we had Forte for and against. The point that we're making is that we had Forte for, which means that there are certainly people who are interested in seeing this happen, and the people who work on the applicability statement and help Karsten out with that should be drawn from the set of people who hummed there. I think the discussion on that, we'll take it to the mailing list. Karsten, please recruit people from among those who were here today, I would expect to see the discussion of that document on the list and to see something relatively quickly that we can take around to transport focused venues to get feedback on and polish up for the next polish up for a next edition of this BOF. With that, we are 2 minutes over. Thank you all very much for a informative BOF, useful discussion. And I wish you all a good rest of your IETF.
We will see you
in not Bangkok.
And we will see you in apparently TSVWG and ICCRG. Thank you all.
Thank you.
Ciao.
Putting this together and the proponents for all their work in getting this to as far as we've gotten.
Yep. Thanks much.
Perfect. So we declare victory and sail into Friday session 2.
We sail into Friday session 2.
Make good choices.
Ciao.
Well done, guys.
Looking at the, thank you very much to the note takers if you're still here. Looking at the notes, they look pretty good, so we'll compile those and get those out soon. All right, ciao.